Give me one moment, guys. Mm. I had something mess up on me. Come on. I know you can do it. There we go. All right. So I'm just going to go ahead and hop into this as long as y'all can hear me. So I'm assuming if I'm not getting any messages, that's good. So, all right. First problem. He went over this at the beginning. F of x equals x squared between 0 and 3, and he wants to use the lower sum with two rectangles of equal width. I hate the use of lower sum and upper sum because if you have an upper sum in the middle of a area, it's annoying. But and he also wants equal widths, so I'm going to say left hand sum. So first things I usually do when I'm solving these is I find delta x, and delta x equals b minus a over n, and n is the number of rectangles, and b is the far right, equals 3 minus 0 over 2 equals 3 halves. So that's delta x. Y'all following along this so far? All right. I don't know if this is how he really taught it and went into it, but this is how I usually like to do it. So now you have summation at k equals 1 to 2 because you want two rectangles. It says it right here, 2. Zoom in. Of x squared, right? And then you got x squared and you have delta xi. But actually, no, I is for something different. Why are you making me do this? I'm gonna see how he taught it real quick. Okay, he went through midpoint and then he did all this. Anyway, so the formula, yeah, I forget how to set that up. All I know is you need delta x. I'm just gonna do delta xi. I'm pretty sure that's it. But so now that equals you plug in your first number, 1 squared times delta x, that's 1/2, plus 2 squared plus, or not plus, times 1/2, which equals 1/2 plus 1, which equals 1/2, or 3/2. Sorry. Pretty sure that's the answer. That's not the answer. Okay. That's 4/2. It's 5/2. Lower sum? Wait a minute. I did it wrong. Sorry. Okay, for left-hand sum. Sorry about this. I did this before, but I deleted everything. You have a, this is going to be, these numbers, B is from, see, this is from the interval A to B. And it's from 0 to 3. That's where I got B and A, and N equals 2 equals number of rectangles. I know how to do to what I delete. Referring to what you delete. I don't necessarily know what you're saying there. I'm gonna draw this graph real quick. X squared looks something like this. And the lower endpoint, and you got 2 intervals, so this is 1/2. Zero, and that's 3/2, because you have 2 rectangles. So you have 1 rectangle and 2 rectangles in the lower endpoint sum. So the low end is 0 over here, so f of 0 times 1/2, or not 1/2, 3/2. That's where I messed up. Okay. Sorry. Plus f of that is f of 3/2 because it's right there, yeah. Halves times 3/2, which equals 0 plus f of 3/2 is 9/4, because 3/2 squared is equal to 9/4 times 3/2, because you have a 3/2 bottom right here. So that equals 27/8. Let's see if that's the answer. And that gives you 3.375. I use a calculator for that just to be sure. Any questions on how I did that? Sorry, I had to get back into the area mood. So I found delta x, which is the width of each blocks, and then you got to add the lower endpoint. Well, the lower end is always on the left for x squared when you're going from 0 to infinity. So that's what I did there. I'm gonna move all this up again. Sophie, did I answer your question or did I make it worse? Okay. I get all my numbers. So you get your range. It's from 0 to 3. A is 0, B is 3, B is your furthermost right. Oh, okay. B is the furthermost right number, so that's why it's 3. And the number of rectangles is n. So I take these numbers, and I come up here and find my delta x. Delta x is nothing but this right here. No. Delta x is nothing but the interval of the bottom of the rectangle. So we find that by subtracting the right endpoint from the left endpoint divided by the number of rectangles. And at this point, it's 3/2. And then we set up our, I forget where the I goes here. I don't think it's delta x. I think delta xi. I think it's f of xi times delta x. Because I think it's, actually, no, that's for the actual Riemann sum. Never mind. I'm trying to get the right formula for you. But I set down the Riemann sum. And we want to know, this problem said the lower sum, okay? So the lower sum in x squared going from 0 to infinity, whenever x is positive, the lower sum is always on the left. Always, no matter what. So we knew we had to start at the left endpoint. So our starting endpoint was 0 for that rectangle right there. That rectangle is 0 because it's on the x-axis. I know it doesn't look like it, but it's on the x-axis. In this rectangle, the endpoint, the lowest endpoint is 3/2. X equals 3/2. And then the height, this right here, equals f of 3/2. No, you can't see that, but all right. So we now have our delta x and our f of 3/2 to solve this. So our f of 0 is equal to 0, or hang on. What you do is you multiply the height of each rectangle times the width. So you got f of 0 times 3/2 and f of 3/2 times 3/2 because you only need 2 rectangles. So you have 3/2. So this one equals 0 because f of 0 is 0. And this one equals f of 3/2 is 3/2 squared because the original f of x equals x squared. So everywhere you have an x, you plug in 3/2. And you multiply it by the width, which is 3/2. And multiplying fractions, you multiply across. 9 times 3 equals 27, and 4 times 2 equals 8. And that equals 3.375. Did I make anything worse by trying to speedily go through that? Because you multiply every term by delta x. Remember the formula he had where he had like delta x times f of x naught plus f of x1 plus f of x2 plus dot plus f of xi. All I did here was I distributed the delta x through all that. This problem, we only have 2 rectangles, so it's delta x times f of x1 plus f of x2, which equals f of x1 delta x plus f of x2 delta x. And f of x1 is our first endpoint, which is 0, and delta x is 3/2. Did that make things worse or better? Or? Okay. Yeah, these problems aren't too hard. The Riemann sums, where you get the exact area in the curve, those can get funky. So y'all are forewarned on those. I'm going to go ahead and try to do this one. Use a finite sum to estimate the average value of the function given it by partitioning the interval. Okay, at the midpoints of 4 subintervals. So they don't have to be equal subintervals. And he just wants you to use the endpoints. So I don't like these problems because you don't know where to start. Okay. F of x equals 5x to the fifth. Let's rewrite the problem. I think that was the answer. Yeah, 1 to 3 and n equals 4. So I'm going to give y'all a choice. Do y'all want equal subintervals to make the process a little more streamlined, or do y'all want to change these subintervals around? Yeah, let's do equal. Trust me, equal is always the way to go. Now we find delta x. Delta x equals b minus a over n, which equals 3 minus 1 over 4, which equals 1/2. And we can get our equation. And we got to use the midpoint, right? Yeah, so sigma of k equals 1 to 3. Did I do this one right? Yeah. This one's 1 to 3. That's where I messed up. I was right. They want 4 subintervals. So you have 4 up here. Sorry. And it's f of x I delta x. So since you have a constant delta x, you don't have to change that. It's fine. The midpoint of each section would be, I would go ahead and line these out. Midpoints are x equals 1/4, 3/4, 5/4, 7/4. You have 4 midpoints for 4 rectangles. Y'all want me to draw this out in the graph so y'all can help visualize it? I don't necessarily know how to graph 5x to the fifth off the top of my head, so I'm going to graph it right here. All right, so we're going from 1 to 3. So 5x to the fifth looks something like this. And say this is 1. I want to use the graph lines, actually. Yeah, let's do that. If we're going to do that, I need to draw bigger, because bigger is better. Okay, so this is 0.14, 1/2, 1, 2, 3, 4. All right. So this is going to get really big really fast. Five. It's going to come out something like this and go up real fast, like way up here. So, and we need 4 rectangles at 0.4 apiece. Well, actually, no, we're starting from 1, aren't we? I got the midpoints wrong. We're starting from 1 and going to 3. So delta, so the x is equal 1 plus 1/4, 1 plus 3/4, 1 plus 5/4, and 1 plus 7/4, because we're starting at 1, not 0. And that equals those are your midpoints. So you have 1 up here. 1 is supposed to go to 5. Just imagine this is a point. You start at 1. This actually works out well. You go to the midpoint. Well, no, let's draw our rectangles first. Our rectangles look something like this, or 1/2, 1/2. That's your delta x. And they go up to where the midpoint touches. Actually, no. They go up to where the midpoint touches and come down to the delta x. See, this midpoint touches right here. They go up to where the midpoint touches and come down. This midpoint touches right here, comes up here, comes down. And we got one more, but it's a little too big because this question gets big really fast. So there's your graph, and you got 3 rectangles. You got one more right here. Comes up. You got 4 rectangles, each with the midpoint. Remember, I asked for the midpoint in the at the midpoints. Yeah, ask for the midpoints. It didn't say equal subintervals, which I don't like, but so that's your area, that's your estimation. You got a little bit less and a little bit more each time to make it more accurate. So now you have your delta x times f of 5/4 plus f of 7/4 plus f of 9/4 plus f of 11/4. And since f of x has a 5 in it up here, we can go ahead and pull the 5 out. So 5 times delta x. Remember, delta x is 1/2 times 5/4 to the 5th plus 7/4 5th plus 9/4 5th. I don't know, right? 4th plus 11/4 to the 5th. And I don't know about y'all, but I'm going to put this in the calculator. I don't know how y'all solve these without a calculator. I would kill myself. I don't even know what 4 to the 5th is. My calculator installed out. Okay, I got something funny, which is probably my fault. I got 586.8 0.016. What's funny? That's 58.6. So you got 586 point. You got what I got, right, Sophia? Oh, what do you mean by average? Oh, hang on, I didn't see that. Oh, wait, does it like want the average value of all the midpoints? Okay. So that's the area. Okay, what does it mean? So 293. So for some reason, if you divide that by 2, you get 293. Yeah. Oh, delta, but I already multiplied by 1/2 right there. That's what I don't get. Did I not do it on my calculator? Okay. So apparently, if you multiply this 1/2, you get 293, and that's the correct answer. I think I was making lunch during that. Don't judge me. Lunch or breakfast. Huh. So when he says he wants the average value, you want to divide it by 2 or multiply by delta. Okay. I guess that makes sense. I'm going to move on though, because this one makes you graph. And it's disgusting. Because like it gives you such a massive graph. And like you have time seconds after injection. The bottom is in seconds, and the top is in milligrams per liter. It's messed up. It should be the other way around because you can't fit this thing on here. But y'all see what I'm saying with this graph? It's labeled wrong. The time should be from 2 to 20, and the other one should be like from like 1 to 5. So I'm going to do something unorthodox, and I'm going to graph it on the y-axis. I'm going to swap these. So this is x, and this is y. Well, no, yeah, time is on the x-axis, but it's wrong. The distances are wrong. So I'm going to say this is the x-axis and this is the y-axis. So at 2 seconds, it's 0.2. At 4 seconds, it's 0.7. 6 seconds, it's 1.9. 8 seconds, it's 4.3. 10 seconds, it's 4.1. 12 is 2.5. 14 is 1.2. 16 is 0.8. 18 is 0.2. 18 is 0.2. And 0. And then I'm going to try to turn this into a graph as best I can. Bear with me. So now that we have that, we're looking for this area right here. Between the y-axis and whatnot. So it wants us to the table. So we can use as many rectangles as we want. I don't like how the bottom's in minutes either. And I don't like how I don't like the units. I'm sorry. This problem's screwed up. What did y'all think about this problem? I'm gonna do 4 rectangles at 5. Actually, this goes like this. So at 5, I'm gonna go 1. That's a rectangle. I swear that's a rectangle. $15. And 20. 20 is kind of 0, but we're going to take a lower limit. But since we know the intervals, we can actually do intervals of 2.2 or 2 seconds. I'm going to do delta t actually. And then, okay, so never mind the rectangles. Once we know the exact values, we're going to say delta t equals 2 because 2 seconds. Each 2 seconds. And we're going to do f of, so it'll be delta t times f of 0 plus f of 2 plus f of 4 so 2 times 0.2 plus 0.7 plus 1.9 plus when I looked at this last night, it looked easier than it was. So the area in the curve, I got 31.8 milligrams per liter per second. And the units don't make sense. So let's do times 60. It gives us 954 milligrams per liter per minute. Okay, what did they say the right answer was on this one? $10.8 liters per minute. This doesn't make sense. The liters is what's screwing with me. Because this one's obviously in milligrams per liter and this one's per second, and that's how you graph this. $5.7. That's the original amount of dye. Was that supposed to come into play? Because all you're looking about is the original. You're looking for the area under the curve, and we graphed everything. And that wasn't supposed to come into play, in my opinion. How many number of rectangles are there? And by the way, this is wrong. That would be 18. I added all those up. Did y'all figure out how to do this one? Sophia? These quizzes don't make. Is this test better than the quizzes? I'm about to just go on. Because this doesn't make. Okay, I think this is a bad problem. First off, the graph is wrong. You can't even graph this problem properly. The axes are messed up. Second off, the units are screwed up. So, um, everybody just know that that answer is this. Anybody watching before or after the fact on YouTube? Yeah, I'm just gonna move on. The rest of these get easy. Okay, sigma notation. So you start at 1 and you go to 2. So that equals 4 times 1 over 1 plus 9 plus 4 times 2 over 2 plus 9. I could pop that in my calculator too. I messed up. And so that equals, yeah, I did it right. Equals 4 over 10 plus 8 over 11, which equals 62 over 55. I put it in my calculator to check myself to make sure I wasn't screwing up because I've not been doing good lately. Y'all probably lost faith in me. But yeah, that's your notation. You start out with 1. Everywhere you see a K, you plug in a 1. Then you go in intervals of 1. Then you go to 2. Say if that was 3, you'd add a third one. 4 times 3 over 3 plus 9. And you add them all together. Okay, so this is a cool problem. So this is these numbers equals 3 to the 0 plus 3 first plus 3 squared plus 3 cubed plus 3 fourth. All right. So if you start out with k equals 1 to 5 through k. I wrote that wrong. Equals 3 to the 5 minus 1 plus 3 to the 4 minus 1 plus 3, I'm going the opposite order, my bad. 1 minus 1, 3 to the 2 minus 1, 3 to the 3 minus 1, plus 3 to the 4 minus 1, plus 3 to the 5 minus 1, which equals 3 to the 0, plus 3 to the first, plus 3 squared, plus 3 cubed, plus 3 to the fourth. And that equals this over here. So option 1 is correct. Now, second one, k equals 0 to 4. And that equals there's the pattern. And the next one is I always hated that you could do negative numbers too. Therefore, all the options are correct. If you were to plug this one in, you would have done the math and saw that those all worked out. I just kind of shortened it for time's sake. Because if we have time, I'm going back to those other problems and we're going to try to figure those out. By the way, if y'all missed the questions on there, or y'all couldn't figure it out, y'all should, if that graph looked like that, you should fuss at them. Not fuss at them, but talk to them. All right, so what do you notice here? I'll even highlight them for you. All right, that's what that equals. But you have differing signs. What is all right? -1 to a 2k power equals 1. Where k is an integer, it'll always be even. Therefore, it'll equal 1. And then in this one will always equal -1 because the power will be odd. This is big boy stuff from Calc 2 that he's throwing in here. It's called an alternating series, but that's beyond recognition. So you want it to alternate. So you don't want it even or odd. You just want a simple k up top, right? So what I would do is I would say sigma, hang on. Yeah. Sigma k equals 1 to 4. I'm just going to say 4 because we have that here. -1 k times 3k. And that equals -1. Okay. You can do that, or you can say that too. -1 to the 0 power times 3 to the 0 power, which equals 1 times 1, which equals 1. But just so you know, plus -1 to the 1 power times 3 to the 1 power. Yeah, 1 power plus -1 to the 2 power times 3 to the 2 power. And that should be 5, I think. Yeah, I messed that up. You can do that. What the -1 up here means is that everything shifted to the left. So what you can do is you can move everything, subtract 1 from everything here on the sigma, and you can get rid of that subtraction sign. It gives you a little bit less calculations. So your answer should be this. Is this what he had in the quiz? Did I do something wrong? Do y'all remember? Okay. This one looks like it would be work, and it still does to me, but I know it doesn't. So you get -3. Oh, I know why. You get -3 to the 1 power plus -3 squared. Only problem that this would work actually is if that started at 0 and went to 4. But since it didn't, you don't get the 1 up here. So that's how that one fails. It started and ended at the wrong spot. Evaluate the sum. Ugh. Did y'all really do this by hand, or y'all just use a calculator? The formulas don't come into play here. I use a calculator. That's just ridiculous. No one knows what 11 cubed is. I'll literally stop at 10. Okay. Okay, so you don't need to find anything. So 2x plus 4. Let's graph the linear. Go throw it back to 8th grade. Booyah. From 0 to 2. And left. How many rectangles? 4 subintervals. So it already gives you these. And once you use the left endpoint, sweet. So you got 4 rectangles, and it wants the left-hand endpoint. There it says it. So what looks like that? B. Any question? Not for this one. That's only for i's when you have i's in there. When you're doing actual Riemann sums. Because then you have ends for formulas and everything. On this one, you just plug in the number cubed, 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 cubed. I'll put it in the calculator. It looked exactly like that. It gave me that answer. So your answer right here is B. It said that one was correct at least, right? That may have been the easiest problem on this whole thing. Go ahead if that was. All right, the norm of a partition. What is the norm of a partition? Do you guys know? I had to look it up earlier. The interval between 3.1 and 4.7. Did y'all know what the norm of a partition was? Okay. I wasn't sure you went over. I had to look it up earlier to be sure. All right, I think this is the last one, and then we can go back, or I can answer some of y'all's questions. Okay. Okay. Oh, why does he want you to form the formula? Ugh. All right. Here's how I do Riemann sums. You just want me to show the limit? Just do it how I normally do Riemann sums and solve for the area. And then we can come back and figure everything else out. Yeah, that's what I'm feeling like doing. I don't like doing his. He gets a lot of his inspiration from Pearson, and it shows. All right, when I do Riemann sums, um, I write down the formula because it's an important formula, and it approaches infinity. Equals 1 to infinity. No, 1 to n. It goes to infinity, but later. F of xi delta xi. All right. Then we find delta x equals b minus a over n, which equals, up here, it's from 0 to 3, so 3 minus 0 over n, which equals 3 over n. All right. And now I find, and delta x times I equals 3 over n I. Nice and simple. So now you just plug it into the formula. You have your delta xi and your delta x on your f of xi. So keep your limit. Did I get up to x squared? Yeah. Okay. And you have f of delta x, or x f of xi is 3 over ni. And actually xi, I was wrong. It's not delta xi. Xi equals a plus delta xi, right? So what that means is you have a. So from this, it's from 0 to 3. A to b. You take your a, which is right here, which is 0, and you add delta x times I. I was skipping that, which equals 0 plus 3 over n I. Does that make sense? I forgot about that A part because it's 0. We all following along? I'm assuming we're all following along. So now we have xi, which is 3 over ni. Now we have delta x. Okay, you find your delta x. You find your delta x, right? Which is 3 over n. 3 over the number of rectangles. We're just going to leave it as n because n is approaching infinity. It doesn't exist. Can't remember if it's, yeah. And then you have xi. Xi is what you plug into this part of the equation right here. Xi equals a plus delta x times I. So you have your delta x, which is 3 over n, and you have a. A is the first term in the is the first coordinate, the first x coordinate. So it's the farthest left, so it's 0 in this case. Is that making more sense? This is the hardest part of setting this up. Okay. Now you come down here, 3 over n I times, and this is not delta x, this is delta x, not delta xi. That's where I messed up. Times delta x, which is 3 over n. You just plug it in. So this equals, and we have f of x, and everywhere you see an x, you plug in 3 over ni. So 5 times you see what I did there? You have 5x squared. Where there was x, I put in 3 over ni and left it squared. Equals, okay. And then we can distribute this 3 over n to the inside. That gotta give me a lot of room. I'm just going to multiply the 5 times 9 times I squared on top. We all following along? So the limit, keep this on the outside. What we can do is now we can distribute this to each of these terms. Limit okay, what's 45 times 3, guys? 90, 135 over n cubed plus I don't know why it does that randomly. To n of 12 over n. Right? So this then, I guess I'll go down here, equals If you can pull out the 135 over n cubed because it's not I. All you just want i's on the inside. Make sure my screen's still there. This is where your I squared comes into play. And you can pull out 12 over n. Times 1. Okay, the limit, that formula, that's like I squared is like, y'all are gonna hate me. But if you factor out the I squared formula, actually, let me try to find the formula so y'all can see where I'm getting it from. I don't want to confuse y'all. I have the factored or like foiled out formulas. Since we got a I squared, let's write this over here. Remember that? Well, if you FOIL that out, that equals that's what I have. No matter what, this will always be true. And this version is 200 times more helpful. I hope y'all can still see my screen. That what you're thinking of is I to the first. That's the formula you're thinking of. This is I squared. Thankfully, we don't have to deal with the I to the first two on this one. But the folded out version is always more helpful, and I don't understand why they give you the factored version. I've never seen it to be more helpful. So 2n cubed plus 3n squared plus n over 6 plus, here you have 12 over n times n. Because a constant multiple rule, it'll be 1 times n right here. So, beautiful thing, those drop. You just get a 12. So now you have a 135 over n cubed times 2n cubed over 6 is n cubed over 3 plus 3n squared over 6 is n squared over 2 plus n over 6. This helps too a lot. Plus 12. Because those cancel, you can just leave it like that. Now, when you're hang on, no, let me not do that. Now you distribute. One 35 n cubed over n cubed, 3n cubed plus and hang on. Okay, well, how's he doing this? We'll work our way back. Plus 12. Well, you can see that those drop, that drops, that turns to 2. And then we get and when you take the limit, those go to 0. And it equals 135 over 3 plus 12, which equals 135 over 3 is divisible by 3. 57. Y'all can still see my screen, right? Wow, it took up the whole page. So we know it's not either of these two. Now let's see what kind of twisted stuff he tries to make us do now. Oh, he didn't split it up. He left it like this. So he wanted it as, I'll write it in green. You wanted it as 135 n cubed plus and I did that way wrong. He just distributed it right there. And the only difference between these two is the power on the bottom. So your correct answer. Oh, finally I can do multiple colors. C. Any questions over that gigantically long process? Any at all? Off the bat, not really. You see how these two answers are the same on the left and the area is different, and these two answers are the same on the right and the area is different. I can say that odds are the powers over here on the top and bottom have to be the same most of the time. They're usually the same for the leading power. That way you don't get something that's infinity and you don't get something that's 0. Because see over here you have a cubed and you have it into the 4th, right? If you take the limit of this, no matter what, it's just going to be 12. You see what I'm saying? And also what's cool about this is this 4 right here. It starts off, the whole thing starts off at 4, right? Because 5x squared is only going to go up, so it's going to look something like this. It's going to look something like that. It starts off at 4. And say this is 3. So that's 3 times 4. That's the area of the rectangle, right? And since it's always increasing, it's never going to get less than that. And you're looking for the area under all this right here. 4 times 3 is 12. So you're just adding what's on top of the rectangle and all this over here, and you're just keeping 12 right there. I don't know if that's cool to y'all. I'm just a little bit of a geek. But the only thing I can really say that off the bat is these two usually have to be the same. I don't know if that helps at all. It's not always, but most of the time. Because otherwise, you did all that work for nothing. Any other questions? I know y'all can go back and rewatch me struggle through this one too. And this is just a long process. It was tedious. Um, so um, there was those couple up front. The beginnings always screw me. This one, I didn't know. I guess I should have paid attention to the class. And this one right here, that's a bad problem. Milligrams just disappears. Anyways, if y'all don't have any more questions, I will catch y'all later. I have office hours tomorrow. We can go over a couple more of these problems. I can put them on Chegg, honestly, and see what happens. If y'all want me to do that. I know those problems from the practice exam I posted in the chat in the group me from Wolfram. And those were ridiculously long. So do y'all got any more questions? All right. If y'all don't got any more, I will see y'all later.